everyone. We're going to be starting chapter 4 now. And chapter 4 has a lot to do with exponents and square roots. So in this lesson, you're going to be writing expressions using exponents, and you're going to be evaluating them. So first, let's talk about some vocabulary. If we have this 3 to the 5th power, this 5 up here is called our exponent, and an exponent tells you how many times to use the bottom number. This would mean 3 times 3 times 3 times 3 times 3, 5 times. Okay, the bottom, this 3, is the base, the number that's being multiplied. Okay, and the whole thing, this 3 to the 5th, is called a power. And the power is multiplication of one number written in simpler form. Okay, instead of writing out 3 times 3 times 3 times 3 times 3, we write 3 to the 5th power. Okay, let's look at some examples. Find each value. So 4 to the 4th power does not mean 4 times 4. It means 4 times 4 times 4 times 4. Okay, you are allowed calculators, and I will show you the shortcut button on your calculator to type in exponents. But for right now, you could just type 4 times 4 times 4 times 4, and you will get 256. Okay. I'll do number 2 and 3, and you can do number 4 on your own. This means 7 times 7 times 7 is 343. 3 to the 5th, we were just talking about what that means. You get 243. Okay. Common error, please realize, is 15 here, or 21, or 16. Just taking the base and multiplying times the exponent. Okay, so be careful. Remember that it's how many times you're multiplying the base. You have 6 squared, or 6 to the 2nd power. All right, next directions are to write each expression using an exponent. So here I have 6 times 6 times 6 times 6. This, written in a simpler form, means 6 to the 4th power. Okay, I'm going to just put the little 4 up there. All right, let's look at a little bit harder ones. P, there's no p's being multiplied with it, so this is just p to the 1st power. You have 1 p there. Okay, here, the thing that's being constantly multiplied is -1. So you write -1, and yes, we put it in parentheses because we're taking that whole thing. 1, 2, 3, 4, 5 times, so to the 5th power. This is different than if you write -1 to the 5th power. Okay, because then you're not taking the negative with it, you're just putting the 1 to the 5th power. The parentheses indicate this whole thing, -1, is being raised to the 5th power. This one, the thing that's being multiplied is 5x plus 1. So we write 5x plus 1, that's our base. We keep the parentheses around it because that whole thing is being multiplied to the 2nd power. Last one, a half, is to the 1st power. We have x, 1, 2, 3, 4, to the 4th power, and y to the 3rd power. Okay. A few more problems and then we're done. Okay, pause me, see if you can fill in each one of these answers, and then we're going to talk about the pattern that you should notice. Okay, the pattern that you should notice would be if I go from 1, as I take away an exponent, that's the same thing as dividing by 4. So if I take 1024 and I divide it by 4, I'll get 256. And if I divide this by 4, I'll get 64, and so on. So if we keep taking away an exponent, we figure out what's going to happen. So now, if I continue this pattern, 5, 4, 3, 2, 1, now we would have 4 to the 0 power. So if I keep keep up the pattern of divide by 4. 16 divided by 4 is 4. If I do 4 divided by 4, you get 1. Okay? And the reason why I had you do this is I want you to realize that anything to the 0 power, any number to the power of 1 will be the base, like we just did. 4 to the first power gives you 4. That's the base. 5 to the first power gives you 5. Any number to the power of 0, 4 to the power of 0 equals 1. 5 to the power of 0 equals 1. 100 to the power of 0 equals 1. Any number to the power of 0 will give you 1. Okay, it does not give you 0. Put a big star by that. Okay, last bit, we're doing some evaluating, which means you're substituting in and solving it. 4 to the power of a, if a equals 2, so you substitute in a. 4 to the second power. 4 to the second power means 4 times 4. 4 times 4 is 16. Okay, this one. Now I'm throwing a negative in at you. Negative 2 to the third power. Negative 2 to the third power. Take away 3. This means negative 2 times negative 2 times negative 2. That will give you a negative 8 minus 3. Yep, it is negative 11. Negative 8 take away 3 is negative 11. Okay, I'm going to let you try this one. This one's a little bit of a challenge one. Okay, you have x equals negative 2, y equals 2. See if you can substitute it in and evaluate. That's it for tonight. Have a good one.